Is it like review? Technically, it's like review. But so what we're doing today is when we learned about these segments, okay, when we learned about these angles, they told us, hey, these lines are parallel. So because these lines are parallel, these angle relationships exist. So today, instead of saying, hey, these lines are parallel, these angles relationships exist, we're going to use the converse. What does the converse do to our conditional statement? It switches it. My conclusion becomes my hypothesis, and my hypothesis concludes. So when I tell you we're using the converse, and I've already told you the parallel lines prove that the angles exist, what do y'all think is going to happen now if we're using the converse? What do you mean we're switching them?
If it says one is
all right, so listen to me. We're using the converse of what I'm about to say. On the first day of this unit, we said that these lines are parallel, so these angles are congruent. What would the converse of that be? If the angles are congruent, our lines are parallel. So we're correct. We're basically starting our review because this is going to help us remember those pesky rules we talked about. So the first one, corresponding angles. Same side of the transversal, same part of their parallel line, or one in, one out. If two lines are cut by a transversal, so that my corresponding angles are what? Was corresponding a supplementary or a congruent relationship? It was a congruent. So as long as those angles are congruent, my lines are parallel. As long as my angles are congruent, my lines are parallel. And who remembers the symbol for parallel on our lines? That's congruent. How did I label lines parallel? That's perpendicular. Arrows on my lines. So remember I put the little arrows on there, the little half arrows? Okay. So when I see parallel lines, if I see these little arrows, that means they're parallel. So because 1 and 6 are congruent, they've got the hoop. There it is. I think it's hoop. I don't know. It's all right. Either way. I can say whatever it is. This is my dictatorship. All right, so as long as 1 and 6 are congruent, J is parallel to K. So that's our corresponding. Same side of the equal sign, side of the transversal, same, both on top of the parallel. Alternate interior. Two lines cut by a transversal so that my alternate interior angles are, was this a congruent or supplementary relationship? As long as they're congruent, my lines are parallel. And then how does it help me know that the lines are the angles are congruent? When I see the what? Nope. Well, if it was a problem, yes. But when I look at the picture, what tells me those are congruent? But how do I know? The hoop. Hoop. There it is. It's okay. It's going to be all right. So when I look at the picture, right? So that means those two angles are congruent. The next picture is the same way. Single hoop, single hoop. All right. Consecutive interior. What was our other name for consecutive interior? What do we call this? No. They are supplementary. Same side interior. Two lines cut by transversal. Consecutive interior angles are what? Supplementary. Oh, Peter. Supplementary. As long as those angles are supplementary, then J is parallel to K. Does 1 and 2 have a hoop? How come? They're not necessarily congruent. Yeah, man. And then our last one was the alternate exterior. Opposite sides of the transversal, outside of my parallel lines. Alternate exterior angles are congruent. If I just had the picture, how would I know they're congruent? What's that? Hoops. Hoop. There it is. What? I don't know. I think it was on Jim Jams, Jock Jams, Space Jams. Okay, so as long as 4 is congruent to 5, J is parallel to K. All right, prove the alternate exterior angles converse. Given 1 is congruent to 2, prove M is parallel to N. So I'm going to go ahead and label my image. How would I label 1 is congruent to 2 on the picture? Single hoop. Hoop, there it is. Hoop. All right. So how do I know 1 is congruent to 2? No. No. It told me. If they did not tell me 1 was congruent to 2, I cannot assume that it is. So first one's always given. How do I know 2 is congruent to 3? Vertical angles, yes. See the X? I know. Perfect. Okay, they went left side on me. They said, we're using the transitive property. So when I look at step 1 and step 2, it says 1 is congruent to 2. So 2 is congruent to 3. Then whom is congruent to whom? 1 is congruent to 3. Good. All right. So how do I know M is parallel to N? I can use a couple here. What do you think? So if 1 and 3 are congruent, so when I look at my picture, we can now say 3 gets this single hoop because it's congruent to 1. When I look at this picture, 1 is on the left side, 3 is on the left side. 3 and 1 are both on top of their parallel lines. What kind of angles do we call that? They're on the same side, 1 in, 1 out. Those are corresponding angles. Good. So corresponding angles converse. And why is it the converse and not just corresponding angles? Anybody have an idea? Why is it the converse and not just corresponding angles theorem? Because we use the angles to prove the lines. If we had used the lines to prove the angles, it just would have been corresponding angles. If we're using the angles to prove the lines, it's converse. Nice and short, right? Not too bad.
Wait, so why is it from the two?
Because we use the angles, 1 and 3, the corresponding angles, to prove that M was parallel to N. If I would have used the M is parallel to N to prove that the angles were congruent, then I would have just used the regular conditional statement. Apply the alternate interior angle converse. Lines P and Q will be parallel if what? As long as what is true? If our marked angles are what? If they're congruent. So if they're equal or congruent, whatever you want to say, but I'm going to say equal. Why would I say equal instead of congruent? I'm talking about what? Talking about numbers. Numbers are equal. Shapes are congruent.
Put equal and congruent?
Well, on this one, because we're specifically talking about those angles, we're talking about equal. But if you want to, you can slap a congruent on there too. Yes, yes, but we use equal when we're talking about numbers, congruent when we're talking about shapes. Yes, more right. All right, so let's plug in what we know. 6x plus 34 equals 9x minus 2. What did they do first? What's that? We can even have a little fun. What if I made this? This is going to make y'all excited. What if I went ahead and said, you know what? This looks a lot like a 2-column algebraic proof. So how about we justify it along the way? What do y'all think? Terrible idea?
Is it required?
Sure. How did I know that 6x plus 34 equals 9x minus 2? Let's call that our given. Yeah. Well, y'all said y'all wanted to review a little bit. Well, somebody said it. I heard them. What? Oh. Yeah, God forbid him wanting y'all to be better at things. All right, what would they do next? What did they do? Added 2 to both sides, probably, yeah. So plus 2 plus 2. So 6x plus 36 equals 9x. What's our justification? Nope, not segment addition, because that's not 2 angles added together. Just the addition property of equality.
Oh, yeah.
Oh, yeah. Back to the fundamentals. Because math is fundamentally fun. What do they do next? Subtract what? Subtract. So the x stayed on the right side, Ethan, so we know they. So 3x and 36. What's our justification for that step? Subtraction property of equality. Beautiful. And what's left? Divide both sides by 3. So x equals 12. So we've got our division property. And just because I'm a pesky math teacher that wants to make sure we didn't jack nothing up, what do you think we should do? Yeah, plug it in, make sure it worked. Those pesky math teachers and all their want to make sure stuff is real. All right, so we're going to substitute. See what I did there? We're going to plug in 12 for both. Yep. 12 minus 2. Anybody got 9 times 12? What? He's got it. Can you do 12 on your fingers? No.
Okay.
Devastating. Yeah, but I don't ever do it that way.
Like that, right?
Yes, or you could just set 9 times 12. He is a smart guy. What'd y'all do? Come on, technology. Why you gotta fail me? All right. 9 times 12 is 108. Easy, easy. There's no need to get hostile. So 108 minus 2 gives me 106. 106 is my right angle. 6 times 12. Oh boy, here we go again. Snap back to reality. Oh, there goes Rabbit. He won't give up, Daddy. You know it.
It's gravity.
I don't know.
It's gravity.
I'll have to look that one up.
Let's listen to it.
Oh, there goes Rabbit. He won't give up, Daddy. You know. All right.
It's gravity.
All right. All right. What?
All right, okay.
72? Thank you. We'll wait. We will see. We riding down the street in my 6'4". And 72 plus. Well, I didn't want to sing that song. No, I ain't singing that whole song. No, I'm good. I've only heard that part. All right, so both are 106. That's okay. That's really okay. All right. Dang it, this thing broke again. I know, I should have. All right, let's go to the next page. Ooh, look at that funness. Oh, man. Is AG parallel, oh, Peter. Is AD parallel to CE? Yes? Well, let's find out. They look pretty even? All right, so, well, in order to prove it, what must be true? Which one what are we going to try to use? So let's find the angle measure of AIJ. So 46 plus 67 gives me what? So I'm going to use, so I'm going to go alternate interior angles because that's the numbers they gave me. Is that okay? Yeah? So do y'all see the alternate? Make the Z, find the knee. There's your congruent angles. Maybe. I don't know. I'm just making up rhymes now. Call me Dr. Seuss of the mathematics world. What? Okay, so 46 and 67. So this is, oh my gosh. So so I'm going to make the AIJ, this angle. So we've got to add 46 and 67 together. 46 plus 67 is what? 113, thank you. and then angle EJI. So we're going to start at E, go to J, and then go to I. What two angles will be added together there? 67 and 50. So 67 and 50. And when that's added together, what does that give me? 17. In order for those two lines to be are parallel, what must be true? Alternate interior angles need to be congruent. Are those angles congruent? They ain't not. So guess what ain't true about these lines? Them rascals ain't parallel, I tell you what. So AIJ and EJI are not congruent angles. What? Are not angles that are congruent. What in the Peter? Okay, so let's go alternate. You never know what they want. Alternate interior angles that are not. So what's that tell me? If the alternate interior angles are not congruent, what does that tell me about my two lines? They're not parallel. Sorry, Charlie. They are not parallel.
Where's Chuck Chan?
I don't know. He's not even in this class. All right. What about BH? BH to parallel to DF. What do you think there? What's the angle measure of BIJ? 67. What's the angle measure of FJI? 67. Are those two angles congruent? Yes, they is. So because those alternate interior angles, it says angles. I didn't have to write angles. Oh, well. Because those are congruent, my lines are parallel. All right, let's do number 3 because I like it. And then we'll talk about perpendicular lines real fast because they go easy. Perpendicular lines are nice and simple. They're BA, is that parallel to DE? Yes? Well, we got to prove it, right? We got to figure out whether or not they is. Or they isn't. Or they ain't not. So in order for, what rule do you guys want to use? I'd probably go same side interior. How come? Why would we be same side interior? He's just messing with you. But this is our transversal right here. Yes, same thing. Yes, so that's our transversal. The blue is our parallel. So why would I want to use same side interior? Same side of the red line, inside the blue ones. Well, Peter, those are my angles I'm going to use. So we're going same side interior. What is that relationship? Come on. What's the relationship for same side interior or supplementary? It is supplementary, yes, sir, which means what? That the measure of 1 plus the measure of 2 equals 180. That's what supplementary means. That's the definition of supplementary. Angle 1's a little tricky, though. What would angle 1 be here? 45 or 90. Which one? It's both.
No,
So take ray C out of the equation. Ray C is just cutting that angle for no reason. This is why I like this question. It's trying to mess with you on a fundamental level. Da-da-da. So 1 is 90 plus 45. And then what about angle 2? What you got? Just straight up 45. 45? Yes? Yes. Equals 180. 90 plus 45 is? Sir. 135. Thank you, Will. 35 plus 45 is? 180. So are my angles supplementary? Yes. So because they're supplementary, what does that mean about? So we are supplementary. Then what can I conclude? BA is what? Parallel to DE. So because they are supplementary, we can conclude BA is parallel to DE. Such a good question. All right, last thing, perpendicular lines. Y'all can erase that and that. Okay, y'all can take out the top two. We'll talk about them later. If two lines intersect to form a linear pair of congruent angles, then those lines are perpendicular. Why? Tail. What does perpendicular mean? Somebody help us out. When it creates a right angle. Two lines intersect at a right angle. So how come when these two lines intersect at a right angle? Well, if it's a linear pair that forms two congruent angles, it must be perpendicular. How come? What's the measure of our straight line? What would the whole line be? 180. So if each one has to be congruent, each angle would be what? 90. So this guy would have to be 90. That rascal's going to have to be 90. So if a linear pair forms two congruent angles, it has to be perpendicular. So if one is congruent to 2, G is perpendicular to H. If two lines are perpendicular, they intersect to form 4 right angles. What's the measure of a right angle? 90 degrees. So therefore, if A is perpendicular to B, 1, 2, 3, and 4 are all what? Nope. Lines are perpendicular. They're all 90 degrees, so what can we say? They're all what? They're all congruent. We could say 90 degrees. We could say they're right angles. Either way, it's all true.
What is more, right?
Depends on what they're asking me. I like that question though, man. Diagram at the right. What can we conclude about A and B and why? It says 1 is congruent to 2. What can we conclude? Come. A is not congruent to B. A is what? Perpendicular to B. Right? And then which one of our theorems? This is where it gets weird. They just start naming. They ran out of cool names for them. Which one? 3.8 or 3.9? Which theorem? 3.8 shows that a linear pair with congruent angles, or 3.9 shows that a linear pair is congruent with three angles? 3.8. So theorem 3.8. They ran out of cool names and just started saying, you know what? We're good. If two sides of adjacent acute angles are perpendicular, then the angles are what? If two angles form a right angle, what do we call them? Complementary. Good. Complementary. What's it mean to be complementary? Not the same. That would be congruent. Their sum is 90 degrees. Good. And I'm not going to make y'all write a blank proof. That's an honors thing. All right, we are done, kiddos. My math lab. Oh, so proofs are a little easier on my math lab because it's like multiple choice. And you can figure out what the best possible fit is. And if you get it wrong, you just hit similar question and do it again. Oh, Peter. So let's go activate.